What do we know about chemistry? For children, it's just mixing chemicals all together. Well, this is not wrong at all. In fact, an important topic in inorganic chemistry consists of mixing reactions. This is the acid-base titration.
The word titles, which means inscription or title. The French word title means rank. Therefore, titration means the determination of concentration or rank of a solution with respect to water with a pH of 7. An acid-base titration is an experimental procedure used to determine the unknown concentration of an acid or base by precisely neutralizing it with an acid or base of known concentration. This lets us quantitatively analyze the concentration of the unknown solution. Acid-base titrations can also be used to quantify the purity of chemicals. The analyte or the titrant is the solution with an unknown molarity. The reagent or the titrant is the solution with a known molarity that will react with the analyte. In acid-base chemistry, we often use titration to determine the pH of a certain solution. The standard solution is usually added from a graduated vessel called a burette. The process of adding standard solution until the reaction is just complete is termed as titration, and the substance to be determined is said to be titrated. All chemical reactions cannot be considered as titrations. A reaction can serve as a basis of a titration procedure only if the following conditions are satisfied. 1. The reaction must be a fast one. 2. It must proceed stoichiometrically. 3. The change in the free energy or delta G during the reaction must be sufficiently large for spontaneity of the reaction. 4th, there should be a way to detect the completion of the reaction. Before you begin with the titration, you must choose a suitable pH indicator, preferably one that will experience a color change known as the endpoint, close to the reaction's equivalence point. This is the point at which equivalent amounts of the reactants and products have reacted. These traits are desirable, so only a small amount of an indicator is needed. If a large amount of indicator is used, the indicator will affect the final pH, lowering the accuracy of the experiment. The indicator should also have a pKa value near the pH of the titration's endpoint. For example, an analyte that is a weak base would require an indicator with a pKa less than 7. Choosing an indicator with a pKa near the endpoint's pH will also reduce error because the color change occurs sharply during the endpoint where the pH spikes, giving a more precise endpoint.
The materials or equipments used in acid-base titrations are a burette, a white dowel, which is used to see a color change in the solution, a pipette, a pH indicator. The type depends on the reactants, an Erlenmeyer or conical flask, a titrant, which is a standard solution of known concentration, and an analyte or titrant, which is the solution of unknown concentration.
For the procedure, the analyte is prepared by dissolving the substance being studied into a solution. The solution is usually placed in a flask for titration. A small amount of indicator is then added into the flask along with the analyte. The reagent is usually placed in a burette and slowly added to the analyte and indicator mixture. The amount of reagent used is recorded when the indicator causes a change in the color of the solution. A setup for the titration of an acid with a base is shown in this figure. As you know from the Henderson-Hasselbalch equation, the pH equals the pKa of the indicator at the endpoint of the indicator. Since we know the pH of the solution and the volume of the titrant added, we can then deduce how much base was needed to neutralize the unknown sample. From this, We can now plot the values in what we call titration curve. Titration volume on x-axis and pH on the y-axis.